Hello again. This lecture is about algorithmic thinking. This follows from the previous lecture that we did last week. So let's think about an algorithm. An algorithm is a step-by-step process of solving a problem. We use algorithms every day. When you cook a recipe or change a tire, do the dishwashing, or you're using algorithms. So algorithms can be sequential or parallel. For example, this can be the sequential algorithm, where sequential algorithms perform each step in the order they are organized, as you can see from this picture. The parallel algorithms, on the other hand, some instructions can be executed in parallel, especially if those instructions are independent. For example, if you have a quad machine, let's suppose that each process in your machine can do a program in parallel. So one part of the process can work on data set 1, the other part data set 2, and so on. So if you have 4 processors, you can say in theory, it will be 4 times faster to do the program. So in this course, we will only focus on sequential algorithms, where we write instructions in a sequence, and Java is a language that supports these sequential programs. So learning to program in language like Java can be complicated. It requires a lot of other things in addition to understanding the language. It can also distract us from the focus on computational or algorithmic thinking that is required to write the program. Therefore, before we introduce you to Java, we look into pseudo-languages. Pseudo-languages are not well defined, but allows us to write algorithms with few high-level instructions. For example, rather than writing a Java program, we might write a pseudo-language program where the steps are very easy to understand. They are written like English type manner, but they are in sequence. So we'll talk about any programs has what called the flow controls. There are 3 types of flow controls in a program. A sequence is a linear progression where one task is performed sequentially after another. While is a loop repetition with a simple conditional test at the beginning. So you could have a while loop here, which iterates again and again doing these instructions until there's a way to get out of that loop and go into the end. If then else is a decision or selection in which a choice is made between 2 alternative courses of action. So in this case, we might take a look at decide to go this way if one condition is true, otherwise we go the other way. And then we go into the third instruction in any case, right? So when you go through this program, either you're going to go through this path or go through that path, one or the other. Input-output programs, all programs need to read and write. We say the program is reading an input, usually from a keyboard. For example, we can say read something. So read is like an instruction in our pseudo language, something, anything you want to define. You can just say read the radius of a circle or read my name. Then the program performs operations and outputs something, usually terminal. You can say display my name, for example. So all programs must have at least 1 or more inputs and an output. So let's take a look at arithmetic instructions next. Most programs do some arithmetic operations such as addition, subtraction, multiplication, and division. In our pseudo language, we will define some instructions as follows. We can say add x to y. This means the value of y is increased by x. Subtract x from y. This means the value of y is now decreased by x. Multiply y by x. This means the value of y is now multiplied by x. Divide y by x. This means the value of y is divided by x. Set instruction. The set instruction allows us the value of a variable, an entity that can change its state, that's what we call a variable, to be set to a specific value. For example, we can say set x to 5. This means the value of x now is 5. In other words, you can change the value of a variable at any point in your program. Compute instruction. Compute instructions, most programs do some computation. For example, you may have to add 2 numbers, multiply 2 numbers, or compute the area of a triangle, our pseudo language provides some instructions like compute expression. So it will compute the value of any expression. For example, you can say compute area as height times width, or compute new balance as current balance minus the withdrawal amount. So there's a keyword here that we need to understand that says area as or new balance as. In this case, we are describing a new quantity that is based on what was computed by the compute statement. So when you say compute area as height times width, the area is now we will be able to display the area after this instruction. Branching instructions. Programs need to make decisions. Depending on the decision outcome, the program may have to transition into a specific instruction. For example, if the number n given as input is less than 0, the program may have to exit with a warning that it cannot perform the computation of, say, square root. We cannot take the square root of a negative number. So in our case, you can say we could just terminate the program or go back to the program and request another number. So until the user provides a number that's greater than or equal to 0, the square root program will not do anything. So in this case, the syntax of this branching instruction is such that if the Boolean expression here is a expression that can either be true or false. If it's true, then you're going to be doing this set of statements. If it's false, we're going to be doing this set of statements. So at any given point, you're only going to be doing either this one or that one. Repetition. Programs are ideal for repeating tasks. Humans get bored if you have to repeat the same thing again and again, but computers will happily do the task for you. In order to ask a computer to do something repeatedly for us, we need to introduce a new construct in our language. So let's take a look at the while construct. This construct allows us to repeat a process a few times. Here's the form of the while construct. While the Boolean expression, as long as the Boolean expression is true, it's going to do these statements. Once it's done these statements, it goes back to the Boolean expression. So as you can imagine, you have to make sure that the Boolean expression can be false sometime at some point. Otherwise, this will go into what we call an infinite loop. There's another instruct that is much more appropriate if you know how many times you want to do something. So you can say, for n from 1 to 10, print n. So this means it will print n numbers. So again, the set of statements between these two keywords, for and n4, will do that many times based on the iteration bounds. Now it's important to have while and end while, for and n4. They are all aligned to show that they are a block. It's a block of statements that you will be doing. So there are some example programs here. So let's take some example programs. So here's an example program in our pseudo language. We have two people, Elian and Anna. So we are counting the cats. So we're going to read Elian's number of cats and Anna's number of cats. And then we compute the sum of cats as Elian's cats and Anna's cats. And we then display the sum of cats. Notice that the sum of cats as, so that means sum of cats is now an entity that we can display. So if you count the number of operations that we did here, this one operation here, one operation, and one operation here, and one operation there. So that means we think each read is an operation, each compute is an operation, each display is an operation. Later on, we will learn how to count operations in more complicated programs. Let's take a look at another program here. So this one says convert pounds to kilograms. So we read the weight in pounds. If the weight is less than 0, we display the message the weight has to be positive. So you may be out of the program from here. If the weight is greater than or equal to 0, we will compute weight in kilometers as weight in pounds times 0.45. And then we display the weight in kilometers. So one can ask the questions, how many instructions will be done in this case? For example, it's possible that it reads the weight in pounds, that's one operation, and then this condition is true, so it's going to do this one here. So altogether, we're going to be doing 3 operations. So one is a read, the other one is a compare operations, the other one is a display. If you do this, it's not going to do these two. So it could be 3 operations, or it could do this operation and compare this and then it can do, in fact, it can only do four operations. So read weight in pounds, compare operation. If it's false, you will go here, do these two. So it'll be three or four operations. So this should be 4. So let's take a look at another one. Here we have multiplying two numbers. So we read the first number as A, second number as B. We set the total of this multiplication. We can just say compute A times B, that's fine. But this is a demonstration of a number of operations that we'll be doing. We are using a loop to multiply two numbers. In other words, we're looking at multiplying two numbers as adding B A times. So that would be the same as A times B. If you take B and add B A times, that would be A times B. If you think about take B and add 2 times, then you get 2 times B. So it's the same way. If you add A times, you will get A times B. So what this loop does is it reads the first number, that's one operation, read the second number, that's one operation, set the total to 0, that's another operation, compare A to A greater than 0, so it's a Boolean condition, either true or false, one operation. Then you compute the total as total times B. So the total is initially 0, now total becomes total times B. Then we subtract 1 from A, so A becomes less now. Then we go back to the loop. At some point, A will become 0. As you can imagine, if you start A with 5, then it goes to 4, then it goes to 3 and 2 and 1 and 0. When A becomes 0, this condition is false, therefore you will be done with the operation. So these are some examples of writing algorithms using pseudocode and sort of analyzing them by counting operations. In the next lecture, we will talk more about these things.